Chapter 1 Integers. Integers. In whole numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, we can subtract a smaller number from a larger number, but it is not possible to subtract a larger number from a smaller number. 7 minus 3 is equal to 4. 8 minus 5 is equal to 3. So, a new type of numbers was introduced denoted by -1, -2, -3, -4, -5, -6, such that 1 plus -1 is equal to 0, 2 plus -2 is equal to 0, 3 plus -3 is equal to 0, and so on. Thus we get numbers as -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. These numbers are called integers. The numbers 1, 2, 3, 4 are called positive integers. The numbers -1, -2, -3, -4 are called negative integers. The number 0 is simply an integer, neither positive nor negative. The integers can be represented on the number line as given below. -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. The arrows on both sides of the number line indicate that the number line can be extended infinitely in both directions. Look at the number line carefully and observe every number on the number line is greater than every number on its left. Example: 3 greater than 2 as 3 is to the right of 2. 0 greater than -1 as 0 is to the right of -1. -2 greater than -3 as -2 is to the right of -3. If a and b are two integers and a greater than b, then -a less than -b. Examples: 3 greater than 1, this implies -3 less than -1. 7 greater than 5, this implies -7 less than -5. Absolute value. The numerical value of an integer, regardless of its sign, is called its absolute value. The absolute value of an integer is always positive or 0. We denote it by x, integer. For example, -5 is equal to 5, 5 integer is equal to 5. Thus, integer x is equal to x if x is positive or 0, minus x if x is negative. Example: simplify integer 7 plus integer -7. Solution: absolute value of integer 7 plus absolute value of integer -7 is equal to 7 plus -7 is equal to 7 plus 7, which is equal to 14. Absolute value -3 plus absolute value of integer -2. Solution: addition of integers. Rule 1. To add two integers of like signs, we add their values, regardless of their signs, and put the comma sign with the sum. Example: add +15 and +8. Solution: +15 plus +8 is equal to +15 plus 8, which is equal to +23. Hence, +15 plus +8 is equal to 23. Add -8 and -5. -8 plus -5 is equal to -8 plus 5, which is equal to -13. Hence, -8 plus -5 is equal to -13. Rule 2. To add a positive and a negative integer, we find the difference between their numerical values regardless of their signs and put the sign of the integer with the greater value to it. Example: add 15 and -7. Solution: positive 15 plus negative 7 is equal to plus 15 minus 7, which is equal to positive 8. Hence, positive 15 plus negative 7 is equal to 8. Negative 13 and 8. Negative 13 plus positive 8 is equal to negative 13 minus 8, which is equal to negative 5. Hence, negative 13 plus positive 8 is equal to negative 5. Subtraction of integers. Rule: to subtract one integer from the other integer, convert the integer to be subtracted to its negative and then add them. Example: subtract negative 8 from negative 15. Solution: negative 15 minus negative 8 is equal to negative 15 plus 8. Negative of minus 8 is 8, which is equal to minus 15 minus 8, which is equal to negative 7. 13 from negative 9. Negative 9 minus 13 is equal to negative 9 plus negative 13. Negative of 13 is negative 13, which is equal to minus 9 plus 13, which is equal to negative 22. Properties of addition of integers. Since all of whole numbers are integers, therefore all properties of operations on whole numbers remain useful. We sum up the properties as follows. Closure property. If a and b are integers, then a plus b is also an integer. Example: negative 8 plus 5 is equal to minus 8 minus 5, which is equal to negative 3, which is an integer. Negative 4 plus negative 3 is equal to minus 4 plus 3, which is equal to negative 7, which is an integer. Negative 9 plus 13 is equal to 13 minus 9, which is equal to 4, which is an integer. Therefore, the integers are closed under addition. Commutative property. If a and b are integers, then a plus b is equal to b plus a. Example: 6 plus negative 11 is equal to negative 5 and negative 11 plus 6 is equal to negative 5. Hence, 6 plus negative 11 is equal to negative 11 plus 6. Negative 9 plus negative 5 is equal to minus 9 plus 5, which is equal to negative 14, and negative 5 plus negative 9 is equal to minus 5 plus 9, which is equal to negative 14. Hence, negative 9 plus negative 5 is equal to negative 5 plus negative 9. Therefore, the sums of the integers remains the same in whichever order we add the associative property. If a, b and c are integers, then a plus b plus c is equal to a plus b plus c. Example: negative 6 plus 7 plus negative 9 is equal to 1 plus negative 9, which is equal to negative 8. And negative 6 plus 7 plus negative 9 is equal to negative 6 plus negative 2, which is equal to minus 6 plus 2, which is equal to negative 8. Hence, negative 6 plus 7 plus negative 9 is equal to negative 6 plus 7 plus negative 9. Therefore, in addition of integers, order does not matter. Additive identity. If a is any integer, then a plus 0 is equal to 0, plus a is equal to a. Examples: 3 plus 0 is equal to 0, plus 3 is equal to 3. Negative 7 plus 0 is equal to 0 plus negative 7, which is equal to negative 7. Hence, 0 is called the additive identity. Additive inverse. If a is any integer, then there exists an integer negative a such that a plus negative a is equal to 0, which is equal to negative a plus a. Negative a is called the additive inverse of a. Example, 7 plus negative 7 is equal to 0, which is equal to negative 7 plus 7. Negative 7 is additive inverse of 7, or 7 is additive inverse of negative 7. Properties of subtraction of integers. Closure property. If a and b are two integers, then a minus b is also an integer. Examples, 11 minus 5 is equal to 6. Negative 13 minus 2 is equal to minus 13 plus 2, which is equal to negative 15. Negative 15 minus negative 8 is equal to negative 15 plus 8, which is equal to negative 7. Therefore, the integers are closed under subtraction. Commutative property. If a and b are integers, then a minus b not equal to b minus a. Examples, 3 minus 5 is equal to negative 2. 5 minus 3 is equal to 2. Hence, 3 minus 5 not equal to 5 minus 3. Negative 4 minus negative 7 is equal to negative 4 plus 7, which is equal to 3. Negative 7 minus negative 4 is equal to negative 7 plus 4, which is equal to negative 3. Hence, negative 4 minus negative 7 not equal to negative 7 minus negative 4. Therefore, commutative property of subtraction does not hold true in integers. Associative property. If a, b and c are integers, then a minus b minus c not equal to a minus b minus c. Example, 9 minus 3 minus 4 is equal to 6 minus 4, which is equal to 2, and 9 minus 3 minus 4 is equal to 9 minus negative 1, which is equal to 9 plus 1, which is equal to 10. Therefore, 9 minus 3 minus 4 not equal to 9 minus 3 minus 4. Therefore, associative property of subtraction does not hold true in integers. Multiplication of integers. In order to multiply integers, we follow the following rules. Rule 1. The product of two integers with like signs is equal to the product of their absolute values with positive sign. Examples, 4 into 6 is equal to 24. Positive into positive is equal to positive. Negative 5 into negative 4 is equal to 20. Negative into negative is equal to positive. Negative 8 into negative 9 is equal to 72. Negative into negative is equal to positive. Rule 2. The product of two integers of opposite signs is equal to the product of their absolute values with negative sign. Examples, 4 into negative 9 is equal to minus 4 into 9, which is equal to negative 36. Positive into negative is equal to negative. Negative 8 into 7 is equal to minus 8 into 7, which is equal to minus or negative 56. Negative into positive is equal to negative. Properties of multiplication of integers. Closure property. If a and b are integers, then a into b is an integer. Examples, 6 into 5 is equal to 30, which is an integer. 8 into negative 6 is equal to minus 8 into 6 is equal to negative 48, which is an integer. Negative 4 into 9 is equal to minus 4 into 9, which is equal to negative 36, which is an integer. 0 into negative 7 is equal to minus 0 into 7 is equal to 0, which is an integer. Therefore, integers are closed under multiplication. Commutative property. If a and b are two integers, then A into B is equal to B into A. Example: negative 6 into 7 is equal to minus 6 into 7, which is equal to negative 42, and 7 into negative 6 is equal to minus 7 into 6, which is equal to negative 42. Hence, negative 6 into 7 is equal to 7 into negative 6. Therefore, the product of two integers remains the same, whatever be the order of multiplication of integers. Associative property. If A, B and C are three integers, then A into B into C is equal to A into B into C. Example: 7 into negative 4 into negative 2 is equal to 7 into 8, which is equal to 56. And 7 into negative 4 into negative 2 is equal to negative 28 into negative 2, which is equal to 56. Hence, 7 into negative 4 into negative 2 is equal to 7 into negative 4 into negative 2. The product of three integers remains the same, whatever be the order of multiplication. Therefore, the multiplication is associative over integers. Multiplicative identity. If A is any integer, then A into 1 is equal to 1 into A, which is equal to A. Examples: 12 into 1 is equal to 1 into 12, which is equal to 12. Negative 5 into 1 is equal to 1 into negative 5, which is equal to negative 5. 1 is called the multiplicative identity property of 0. If A is any integer, then A into 0 is equal to 0 into A, which is equal to 0. Examples: 0 into 6 is equal to 6 into 0, which is equal to 0. Negative 5 into 0 is equal to 0 into negative 5, equal to 0. Distributive property of multiplication over addition. If A, B and C are three integers, then A into B plus C is equal to A into B plus A into C. Example: negative 4 into negative 5 plus 3 is equal to negative 4 into negative 2, which is equal to 8. And negative 4 into negative 5 plus negative 4 into 3 is equal to 20 plus negative 12, which is equal to 8. Hence, negative 4 into negative 5 plus 3 is equal to negative 4 into negative 5 plus negative 4 into 3. Multiplicative inverse. Multiplicative inverse of non-zero integer A is 1 upon A. A into 1 upon A is equal to 1 upon A into A, which is equal to 1. Examples: multiplicative inverse of 7 is 1 upon 7. Similarly, 7 into 1 upon 7 is equal to 1. Multiplicative inverse of negative 8 is minus 1 upon 8. Similarly, negative 8 into minus 1 upon 8 is equal to 1. Division of integers. Like the whole numbers, division of integers is inverse of multiplication. Dividing 18 by 3 implies that we have to find an integer which, when multiplied by 3, gives 18. Obviously, such an integer is 6. 18 divided by 3. Let us recall few definitions relating to division. Dividend. The number to be divided is called the dividend. Divisor. The number which divides is called the divisor. Quotient. The result of division is called the quotient. Remainder. The number that is left over in division is called the remainder. To find the quotient of two integers, we have the following rules. Rule 1. If two integers are both positive or both negative, then absolute value of two integers are divided and positive sign is assigned to the quotient. Examples: 12 divided by 4 is equal to 3. Negative 42 divided by negative 7 is equal to 42 divided by 7 is equal to 6. Rule 2. If two integers are of different signs, then absolute value of two integers are divided and negative sign is assigned to the quotient. Examples: negative 26 divided by 2 is equal to negative 13. 24 divided by negative 6 is equal to negative 4. Properties of division of integers. Closure property. If a and b are integers, then a divided by b is not always an integer. Examples: negative 14 divided by 2 is equal to negative 7, which is an integer. Negative 15 divided by negative 3 is equal to 5, which is an integer. Negative 7 divided by 2 is equal to, result is not an integer. Negative 13 divided by 3 is equal to, result is not an integer. If a is an integer such that a not equal to 0, then a divided by a is equal to 1 and a divided by 1 is equal to a. Examples: 7 divided by 7 is equal to 1. Negative 8 divided by negative 8 is equal to 1. Negative 9 divided by 1 is equal to negative 9. For any non-zero integer a, 0 divided by a is equal to 0. Examples: 0 divided by 6 is equal to 0. 0 divided by minus 6 is equal to 0. If a is an integer, then a divided by 0 is equal to a upon 0 is not defined. Example: find the quotient in each of the following cases. Negative 63 divided by negative 9. Negative 63 upon negative 9 is equal to 63 upon 9, which is equal to 7. Word problems. Example: in a class test containing 10 questions, 4 marks are given for every correct answer and negative 2 marks are given for every incorrect answer. Naresh attempts all questions, but only 8 of his answers are correct. What is his total score? Umesh also attempts all questions, but gets only 6 answers correct. What will be his score? Solution: correct answers is equal to 8. Marks given for 1 correct answer, 4. Marks given for 8 correct answers is equal to 8 into 4, which is equal to 32. Marks given for 1 incorrect answer is equal to negative 2. Marks given for 2 incorrect answers is equal to 2 into negative 2, which is equal to negative 4. Total score of Naresh is equal to 32 plus negative 4, which is equal to 28. Therefore, total score of Naresh is 28.